Okay, this video will introduce you to the different ways that we can draw organic structures or different types of notation for them. There are often several different ways or even many different ways in some cases to draw the same thing. So first we're going to go over them and then practice. So we can have molecular formulas for organic molecules, and the molecular formula just tells us the number and type of atoms. It's an atom count. It's like saying H2O for water. CH4 is a molecular formula. So here we've got the formulas CH4, C2H6, and C3H8. Then we can have our complete structure. In our complete structure, we draw every single bond to every single carbon-carbon bond and carbon-hydrogen bond. All the bonds are drawn out in a complete structure. So this includes all the bonds. We can have a condensed structure. In a condensed structure, we're usually getting rid of something, showing a few less bonds. For example, we don't have to show every single carbon-hydrogen bond in a condensed structure. Instead of showing, a carbon with every single hydrogen bond, we might abbreviate it CH4, CH3. In a skeleton notation, we just write out the carbons and how they're bonded to each other. And then in a line angle notation, we draw a line for every single CC bond. So in a line angle notation, the line represents a carbon-to-carbon bond. Okay, so let's look at the first example. We've got CH4. So in a complete structure, we would show our central carbon. It had 4 valence electrons, and so we're showing it bonded once to each of 4 hydrogens, and that would just be methane or natural gas. So we're showing how every single every single one of those 4 carbon to hydrogen bonds looks. When we go to condense it, we can just write out CH4. The condensed happens to be the same as the molecular here. And then a skeleton notation for this, just 1 carbon. So we wouldn't really do that, per se. We'd usually write out at least CH4. And it doesn't really have a line angle for just methane. But starting at C2H6, we can start to see the utility of these different structures. So if we're going to draw out C2H6, we draw out carbon bonded to carbon, and then we surround those 2 carbons with hydrogens. So they need to get surrounded with 6 hydrogens. There's always 3 hydrogens on every end carbon. And there's actually a useful formula for alkanes. It's CnH2n plus 2. So in other words, when you have all single bonds, your hydrogen count is going to be 2 times your carbon count plus 2 extras. How does that make sense? Well, there's 2 hydrogens on every carbon, plus you also have to add the 2 end hydrogens. So there's your plus 2. And so we can condense this down and show that each carbon had 3 hydrogens around it, or we can condense it down to CH3, CH3. And in the condensed one, we could show a line between the 2 CH3s if we want. In the condensed formula, we tend to show the CC bonds. And then the skeleton notation is just the 2 carbons connected to each other. So C bonded to C. And a line angle, here's what's interesting. With a line angle, every point counts for a carbon. So here's your first carbon. We draw 1 line. The next point's your second carbon. So it's actually represented with just 1 line. So again, in that condensed structure, we're showing just the carbon-to-carbon bond. And then in that line angle, every point's a carbon. So the 1 line does actually represent 2 carbons. So that's the thing with line angle. There's actually 1 less line than carbon. So I'll just write that down. 1 less line. Oops, I meant to say line. Line. Then there are C's, which is kind of a weird thing. So there's 1 less line than there ever are carbons themselves. Just thought that's worth noting. Okay, and in our last example, we've got C3H8. So we've got 3 carbons all in a row, 1, 2, 3. We've got 2 CC bonds, and then we've got 2 hydrogens on every carbon, 1, 2, 3, 4, 5, 6. And then there's end hydrogens, so there's 7, 8. So with C3, it's H2N plus 2. Well, that's 6 plus 2 more is 8 hydrogens. So in our condensed structure, we still have a line for each CC bond, and we have CH3 on the end. Well, that corresponds to this CH3. Then we have CH2 in the middle. That corresponds to the middle carbon. And then we have CH3 on the end. That corresponds to the end carbon on the right. When we go to draw the line angle structure of 3 carbons, we'll only need 2 lines because there's 2 CC bonds. I always count the first point as carbon, and then, so that carbon was 1, and then 2, and then 3 carbons. So 2 lines for 3 carbons. 1, 2, 3 carbons. Again, with line angle, you count this first point before you even move your pencil. 1 carbon, 2 carbons, 3 carbons. So there's your line angle for 3 carbons. Actually looks like a V. It just looks like the letter V. Okay, so next we're going to try some practice with drawing organic molecules in our after class problems. So in the first example, all we've been given is the condensed structure. We've got CH3, we've got CH2, 4, meaning there's 4 of those, and then CH3. So maybe let's start with our skeleton notation. We've got the carbon on the end, then we've got 4 in the middle, 1, 2, 3, and 4, and then I'm running out of room, but the last one on the end. So here was my CH3 on the end, and then let's double check that I have 1, 2, 3, 4 in the middle. Great. In my line angle notation, I've got a total of 6 carbons, so I want to start with a point out here and call that carbon 1, and then my next point is carbon 2, so I've drawn 1 line, carbon 3, 4, 5, 6. So I want to double check my carbons. 1, 2, 3, 4, 5, 6. So notice how it only took me 1, 2, 3, 4, 5 lines for the 6 carbons. So 5 lines for my 6 Cs. Now I've got to go back and draw up a complete one, kind of avoiding that. 1, 2, 3, 4, 5, 6. And then I'll go through and I'll draw in my hydrogens. Okay, so if I had C6 for this one, I had to have H2N plus 2 or 14. So my 6 carbons each have 1 hydrogen going up, 1 hydrogen going down, that's 12. And then here's my 13th and 14th hydrogen, 1 on each end. Ooh, got a line there. I have to erase that to do my next one. Okay, now in my next structure, I've got a complete structure. It looks like there's a CH3 on the end, then there's a C, then coming down from it is a CH3, and going up from it is a CH3. I move one to the right, and there's a CH2. And then I move another one to the right, and there's a CH with a CH3 coming up. And then lastly, a CH3 on the end. So going left to right, there were 1, 2, 3, 4, 5 carbons. I'm going to just go ahead and put those in my skeleton. 1, 2, 3, 4, 5. On the second carbon, there was a carbon coming down and a carbon coming up. The third carbon was fine, no groups. The fourth carbon has a carbon coming up from it. I think I'll tackle the line angle next. I'll do carbon 1 as my point, carbon 2 up, carbon 3 down. It's like my upside down V. Carbon 4 up, and carbon 5 down. So I have 1, 2, 3, 4 lines for my 5 carbon chain. Then I should have a group coming up from the second carbon, it's like the first intersection, but it's the second carbon. And I'm going to do a group coming down from that one. And then I'm going to skip over to carbon 4 here and do a group coming up. So at carbon 4, it's like the third intersection or the fourth carbon in my chain. So this kind of looks like an M, if you will, and in the M, there is another line coming straight up from the top points of both M mountains, and then one M mountain has a line coming down. And so that ends up looking like my zigzag structure. Okay, now I need to look at a condensed structure. My first carbon needs to have some CH3s on it. This is really my first carbon, and it has 1, 2, 3 CH3s on it. So this is going to be CH3, 3, and then there's a C, and then there's a CH2. So now I've gotten to here. I'm kind of out of room, so I'm just going to draw a line. And then there'll be a CH, and on that CH, there'll be 2 CH3s. Oops, there should be a 3 there. Should be CH3, and there are 2 of them. So the condensed structure was CH3, 3, and then there's a carbon, and then there's a CH2, and then a CH with CH3, 2. Ooh. Okay, let's just clear that so we have room to think about our last one. In our last example, there's a skeleton notation with 1, 2, 3, 4, 5 carbons. So we'll do a line angle with 4 lines. 1, 2, 3, 4. Let's double check that there's 5 carbons. I'll count the points. 1, 2, 3, 4, 5. Perfect. So how will this look if I draw it out? Maybe I'll do the complete one first. 2, 3, 4, 5 carbons. And then I'll fill it in with 1 hydrogen above each carbon. So then I'm at 5 and 1 hydrogen below each carbon. So then I'll be at 10 before we know it. And then here's 11 and here's 12. And so how would we condense this? Well, we'd have CH3 on the end. We'd have 3 of the CH2s in the middle, and then CH3 on the end for our condensed structure. So hopefully now you feel confident that you can draw various organic structures.